Hey everyone, welcome back, and today let's solve Leetcode problem 1106 titled Parsing a Boolean Expression. So a Boolean expression is an expression that evaluates to either true or false, and it can be in one of the following shapes. So the string t is going to evaluate to true, while the string f is going to evaluate to false, and while this string right here, the exclamation mark, is going to evaluate to the logical not of the inner expression. The and operator is going to evaluate to the logical and of the inner expression from sub-expression sub1, sub2, up until sub-expression sub n, where n is greater than or equal to 1. And this absolute value looking operator is going to be evaluating to the logical or of the inner expression from sub-expression sub1, sub2, up until sub n, where n is greater than or equal to 1. So we're given a string expression that represents a Boolean expression, and we have to return the evaluation of that expression. And it's guaranteed that the given expression is valid and follows the given rules. So in example 1, we have the input string expression to be the following, and we'd output false. The reason why is because first we have to evaluate the or f is going to, so now it's going to be and f, right? Because again, this absolute value looking operator is going to be the logical or of the inner expressions. And then we're going to have again the the and f. And then we have to evaluate this and f to be just false. So the expression is now just a string of f, and so we output false. In example 2, we have the input string expression to be or f, t, and we'd output true because the evaluation of false or true is true. Okay? And in example 3, we have the input string expression to be the following, and we would output true because first we have to evaluate and then f and t, which is false and true, which is going to be false or f, and so the expression now is exclamation point or not f, and so the exclamation point f is going to be not f or not false, which is obviously true, and so we'd return true as our final evaluation for this input string expression in example 3. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. And I'll talk a little bit slower for you guys to really understand what I'm really doing. Okay, so this is a pretty lengthy problem statement, and it can be a little bit difficult to really understand what it's saying. So I'm going to try to summarize this problem statement for you, but still keep it as concise and straightforward and clear as possible. Okay, so we're given a string that represents a Boolean expression, and it consists of operators exclamation point, which is just not, the and sign, which is the logical and the absolute value operator, which is just the logical or. And we have operands t or true or f or false, and we just have to evaluate the expression and return a Boolean value based on that logic. So the input for this string is going to be simply a string, like consisting of the and, not, and or operators with true and false operands. And for our operators, the and operator means that all sub-expressions must be true. The or operator means that at least one sub-expression must be true, and the not operator simply negates the expression. So the way we're going to really structure our algorithm is we simply have to use recursion to parse the expression recursively, and we're going to break it down into smaller parts until we actually reach t or f, or true or false, the value that we have to output based on the Boolean status. So we'll create a helper split expressions function to correctly split sub-expressions separated by commas. And again, this is going to recursively evaluate the Boolean expression based on the operator and return that result. So with that out of the way, let's just go ahead and dive straight into the code here, right? So I'm just going to directly define that helper function. I'm going to call it evaluate, right? Evaluate. I think that's how you spell it. Correct me if I'm wrong. I think so, though. And of course, for the parameter, it's going to take an expression. And ultimately, once we're actually calling this evaluate expression, we're actually going to pass in our actual input string expression as the parameter to actually accurately, get the value or Boolean value of our input, right? So again, to better explain what this does, in the main function, we have to define this nested helper function that actually takes a smaller expression and returns its Boolean value, right? So first, we have to have a first conditional to check if the expression that we're looking at, or the parameter, if that's equal to the string of t. Great, we've hit that base case, we can return true for our recursive algorithm. However, if the expression is equal to an f, that means it's false, we've had another base case, and we can return false as the Boolean value or status of that input, right? And it's basically the exact same logic as the lines 4 and 5, right? And of course, if none of those are true, we can extract our operator. So I'm going to call it operator. And I'm going to initialize it to be the expression's first index, or I guess 0th index, because of course all the iterables like strings and arrays are going to be 0 indexed in programming, right? So again, the operator is going to be the first character of the expression. So for example, if the expression was and ... the operator would be just a string of and, okay? So once we actually extract this operator, we want to also extract the content. So I'm going to say content is going to be equal to expression, and I'll use some list slicing here in Python, so it's from the second indice or indice 2 up until the -1, right? Where we basically remove the outer parentheses and the operator from this expression and the content. And so if the input was per se and parentheses tf, the content would then be just the string tnf. And in fact, I'm actually going to comment that out. Example, if the string or input, I guess, was the string of and, where's and on my keyboard, there it is. And then, I don't know, let's say we have parentheses t and f. Oh yeah, just realized. Okay, t and f. In that case, this would evaluate, or the content for this would just be the string of t and f. Oops. We'd remove the outer parentheses and the operator, right? And we simply get the content to be true and false, okay? So once we do that, we want to get parts to actually be split expression, right? Our second helper function that we'll define later, with the parameter actually being the content itself that we defined on the line above, on line 9, right? So we're basically using this split expressions helper function to split the inner content by commas, right? And then this basically ensures that sub-expressions within nested parentheses actually do remain intact, right? And again, we'll define this split helper function later on in the code, okay? Once we do that, we actually have to check if the operator, I think that's how you spell oops, if operator is actually equal to an and symbol, there it is on my keyboard, then we need to return all, because that's how the and operator is defined, evaluate, passing in parameter parts for every part, for every part in parts. Right, quite straightforward, because again, if the operator is an and, we have to recursively evaluate all those sub-expressions, and so we'll use all in Python to ensure that every single part actually does evaluate to true. Right, that's what the all keyword does in Python. So else if, or just elif in Python, oops, it's just elif in Python, if the operator is actually equal to the or operator, or operator, then we know that we have to return any one of the evaluating at part for every part in the parts. Right? Because again, if the operator is or, we have to recursively evaluate all these sub-expressions again, but we have to use any in this thing because any, at least one part would evaluate to true. Instead of all, we'd simply use any, because at least if one part evaluates to true, then this operator is actually valid. And finally, if operator, or else if again in Python, if the operator is actually equal to a exclamation mark or a not operator, we simply have to return not of evaluate at parts at index 0, right? Because if it's not, we have to negate the result of that first part, okay? So once we actually do this, we're done with our helper function evaluate, and now we actually have to define our second helper function, which I'm going to call split expressions, like we used up on line, I think it was 9, right? Or sorry, 10, split expression. And for this split expression helper function, we're going to take in content as our parameter, right, as we saw on line 10. So again, this is going to correctly split the expressions that are separated by commas, and it ensures that nested parentheses are actually taken into account when splitting. Okay, so once we do that, we're going to have our parts to be an empty list. Oops. We're going to have our balance to be equal to 0 because we haven't actually done anything yet, and we'll have our current to be an empty list, where again, parts is going to be used as a list to store individual sub-expressions, and balance is going to track how deep we are inside our nested parentheses, and current is going to temporarily store characters for the current sub-expression. So once we do that, we want to actually loop through every single character in the content. So I'm going to say for char or character in content, you can call it whatever you want for your iterator. So for character in content, we basically have to loop through every single character in that content string. And now, if the current character that we're looking at, if that's actually equal to an opening parentheses, we have to increment our balance by 1. And of course, if that's not the case, so if the character is equal to an closing parenthesis, then we have to decrement our balance by 1. Where again, we have to adjust the balance whenever we actually encounter an opening or closing parenthesis. I don't know if I used bracket before. I meant parenthesis if I did. But again, once we cover that through those conditionals, we have to check if the current character that doesn't evaluate to true is equal to a comma. I know it looks weird, but that's how it's structured. And our balance is still equal to 0. Then we know we can append to our parts. So parts.append our or actually I have to do string.join, right? Because current is actually a list right now. The string.join of current. Or again, string.join basically takes all those elements of that list and converts them or joins them into a single string, right? Which is very helpful in Python for cases like this. And then we'll set current back to be an empty list again for future iterations, because we want to have a list again to actually append values to it. And then finally, we'll have an else conditional. And if that's the case, we simply have to current.append char regularly. Okay, so to kind of summarize what this does is if we actually find a comma and we're not inside the nested parentheses, we have to store the current sub-expression in parts. And otherwise, we can keep adding to the current list until we actually do that. So once I actually am done with that for loop, outside of this for loop, I want to parts.append the string.join of the entire current list so far, or whatever it is after this for loop, and we have to simply return parts. Okay? And once I actually do that, once I actually add the final sub-expression and return the list of parts, I can simply exit this function and return the evaluate, passing in my actual input expression string as my parameter, right? Because we have to call this evaluate function on the original expression and actually return that result or that output, right? And if I were to submit this right now, unless I made any syntax errors here, this should be accepted. And as you can see, this is just about as efficient as you can get. So to better explain what the code does overall, right, this parse bool expression function simply takes a Boolean expression string, and we have to recursively evaluate it using the evaluate function and ultimately return the final Boolean result. And we have to use these logical operators like and, or, and not, and we have to handle nested expressions correctly with the help of the split expressions helper function. So for the time complexity of this code, this is going to be big O of n, or linear time, where n is the length of the input expression string, and that's mainly because we parse the entire expression once and just simply split it into parts, right? And the space complexity is also going to be big O of n due to that recursion stack and the space needed to actually store all of those sub-expressions. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.